All right, hey everyone, welcome to the latest lesson in Python. We're going to be going over using lists this time. I'm Samith.
I'm Joe.
And I'm Noble. So first we want to talk about what exactly are lists. So in Python, a list is a container that can hold a group of objects, and they are all assigned indexes to put them in sequence. They are in order, just like a real list you would make. The indexes are represented with numbers, and the first index of a list always starts at 0. So you start counting from 0 and go 1, 2, 3, and so on. And it basically is a way of keeping track of the position of the different objects in a list. And lists go left to right. A list can have strings, integers, floats, characters, pretty much any type of object. It can even have a pointer to another list. So they're very flexible containers and great data structures. So if we look at my example here. So in EduBlocks here, we have a list that I made, my list. And as you can see, there's all different types of objects in there. So I have some integers, 1, 2, and 3. I have some letters, which are characters, A, B, and C. And then I have 2 floats at the end, 4.0 and 5.0. So you can mix and match different things in terms of the object types, or you can have a list of all ones. And so first I printed it, as you can see. Let's go ahead and run it first, actually. Yeah, so first I printed the list so we can see what's in there. And then I called the objects at certain indexes. So index 0, if we remember, is our first index. So as you can see, it returns 1 because 1 is the first element in our list. And it's very important to remember that index 0 is always going to bring you the first element. It's not index 1. So we have 0 is 1. We have at index 5, we have C. So if you count and see, it's actually the 6th element, but because we started 0, 5 is C, and then of course 7 is the last one, which is the 5.0.
Okay, so when we're working in EduBlocks, we need to be able to make lists. And to make lists, we want to head over to the EduBlocks tab, and that's labeled as lists. It's that nice blue color. So if we head over to the project, we can take a look at that. So right on the side there, it says lists. It's kind of like a teal. You can click on that, and it'll bring up a bunch of different options. And that first one there is what you would use to create a new list. And so you can create a name for it, but we're just going to keep with my list. So here in my list, we are adding 4 values, 1, 2, 3, and 4. And Noble showed that we can print them out just by using print. But occasionally, we may want to access every single value in an array. And in order to do that, we need to use a for loop. And the reason we're using the for loop is because there are 4 values in here, and we want to look at it 4 times. And so that each time it runs, it'll look at the new value. So if we look at it right here, it'll print 1, 2, 3, and 4. It's a little bit more complicated than what Noble showed, but we'll show you later on why you may want to do this. Lists have some interesting effects here. So we'll worry about append a little bit later. Let's look at adding new items, or not adding new items, but declaring new items. So the data that's stored in a list isn't permanent. It's kind of like if you were to write down a list of chores you need to do on a piece of paper, you can erase one of those chores and write something new in. So just like before, we're creating a list with 1, 2, 3, and 4, but this time we are changing the values to 5, 6, 7, and 8. So like Noble said, we're starting at value 0. So 0 will go from being equal to 1 to being equal to 5. And then value stored at position 1 will go from 2 to 6, so on and so on. And so if we run through the program this time, it should print out 5, 6, 7, and 8. So we can change the values stored in there. And the last very basic feature of lists is being able to do math with them. So it should be that little bottom tab there. There we go. So if we look at this piece of code right here, we're creating a new value called total. And then we're going to loop through the list like we did to print everything out before. But rather than printing it out, we're going to add the value that's being stored there to our total. So the first time it goes through the list, it'll be equal to 1. And the second time it'll be equal to 1 plus 2, which is 3. And then 3 plus 3, which is 6. And then 4 plus 6, which will be equal to 10. So if we run it, it should be equal to 10. Excellent, it is. And if we were to change the numbers in here, so if we were maybe change the 1 to like a 5, we could expect a 14 in there because 1 plus 2 plus 3 plus 4 is 14. Or maybe we wanted to add more values in there, we could do that as well. But this is the power of lists because we can store a bunch of information inside them and then we can do math and do some cool stuff with them later. You have to change the range on the for loop to make that work. You have to bump that to a 5. And that should make it to a 24. All right.
Okay, so like we alluded to earlier, there's a couple special functions we can perform with lists, and a function is just a piece of reusable code that we have. So the basic ones are, I can open it up in EduBlocks. The basic ones are append, which just adds an item to the end of your list, similarly to if you have like a grocery list and you realize later on, hey, I also need this item. You can just add that on to the end. And then as you see here, when we print this out, we started off with 1, 2, 3, and 4. We appended 5. And so when we print out the list, they're all in the list together. That's append. It's pretty simple, just adding to the end of a list. But sometimes you don't necessarily want to add on to the end. You might want to add to the beginning or in the middle. And that's why we have the insert function as well. And the insert function, it takes both a number, right, the number you want to insert, but also you have to tell it where do you want to put it. So here we tell it to go to index 1, which keep in mind, once again, we start counting from 0. So this 1 here is at index 0 and the 2 is at index 1. So when we run this piece of code, the 5 should go before the 2, right here at index 1, and it pushes the 2, 3, and 4 backwards in the list. So that's the insert method. It's also useful for adding new items. But now we need to figure out a way to get items out of the list. And for that, we have the pop method, among other things. So here we tell it the position of the item that we want to remove. So if we say pop 2, what that'll do is it'll go to the second index. So in this case, 1 is at index 0, 2 is at index 1, and 3 is at index 2. And when we call this function, we will remove that 3. And that's how it works. So you can give it any number. If you passed in pop 0, what it would do is it would take out the number at index 0, which is the 1, and you're left with 2, 3, 4. So those are the 3 very basic methods we have for interacting with lists. But now sort of moving on to more advanced topics, how do we interact with lists in general? So if we go to our next EduBlocks, we have sort of the very basic way that we can select an item out of our list. And we've brought this up earlier, which is indexing. If we want to pick a very specific item, if we wanted this single number, maybe at the 3rd index, which is in this case 4, we can just access that with the use of these square brackets, and then we put the index in the middle. So when we run this, it'll print out the 4. And we could select any index we want. We could do index 0 and it would pick the first one, so on and so forth. But going a little bit more advanced, maybe we don't just want a single number. Maybe we want a whole piece of the pie. We want a slice of this list. And to do that, we do what's called slicing. And we put this sort of, it's a colon, and we have both a start index and an end index to describe a range of the list that we want to get. So I'm just going to run this code and we'll see what happens. We get 2, 3, and 4, which you'll notice 2 is at index 1 and 4 is at index 3. So why is it not giving us the 5? Well, as it turns out, in Python lists, the way you select a range is by giving it a start value and then an end value. But when you grab that, it's going to be exclusive on the end value. So it's going up until the 5, but not including it. And that's how taking slices works. You just have a start and an end. You could also leave it blank. So if we don't give it a start value, it'll just start from the very beginning. So it'll go from 1 all the way up until the 5, but not including the 5. And likewise, if we gave it a start but no end, it would just go all the way until the last one. So in this case, it's going to start with the 4 and then just go to the end. So that is very basic slices. But what we could do as well is specify a third number. So here, if we say had start and end values here, it would go from that range as we just saw. But if we exclude both of them, it'll just go from the very beginning to the very end. And this third number defines our step size. So that's essentially the gap between each jump. Rather than going one at a time, we could go every other number if we do 2 here. We could also start at 1. So that's starting at this number 2 and then jump 2. So we'll get 2 and 4. So these are just very basic things that you can do to go over parts of the list if you want to access very specific values within it. And lastly, the way that you will often see lists be used is through iteration, as we showed you earlier. So before we were running through and adding numbers to a running total to a variable. But what's really the use case in that? Well, let's say you're a teacher and you're trying to calculate maybe the average for test grades. So you have a list of your test grades here. Hopefully these, if you're a teacher, these aren't your test grades, 1, 2, 3, 4, and 5. But let's just say that maybe the test was out of 5. And if you wanted to calculate, say, the mean, what you could do is you could have, the sum, and then you would, for each of these numbers in your list, just add that sum, or add each number to this running total. And then you could print out the sum, which would give you the absolute total. But let's say if you wanted to calculate the mean, you could just do a little bit of math to divide the sum by the number of numbers that you have. So that would be, in our case, 5. And if we print that out, you'll see we got 3.0, which is the average of this data set. If we had maybe 190, so on and so forth, it would print out the average of whatever that is. So you can see sort of the versatility of lists and the way that you can use iteration to run a repeated process over all of them. And so with that, that is the overall breakdown of lists. We encourage you to just sort of play around more with it. And yeah, thanks for watching.